Alright, today we're going to be talking about how to divide polynomials. We're going to start by dividing polynomials using long division. So to divide a polynomial, first off, by a monomial, you want to find the quotient of each term of the polynomial and the monomial. So if we have 6x squared minus 15x over 3x, so that's 16x squared minus 15x divided by 3x, all we have to do is break the polynomial apart into two terms and divide each term by 3x. So 6x squared divided by 3x is 2x, and 15x divided by 3x is negative 15x divided by 3x is negative 5. So that is how we divide by a monomial. If we're dividing a polynomial by a polynomial with more than one term, we're going to use a process similar to long division, just like we did, way back in 4th and 5th grade. This process is known as the division algorithm, and the resulting quotient may be a polynomial or a polynomial with a remainder. So, just think about when we're dividing. If we're dividing a polynomial by a polynomial, that's going to equal a polynomial, right? So, think about this. If f of x divided by g of x, right, so a polynomial divided by a polynomial, that's going to equal a polynomial. So, in the same sense, that means that the f of x that we were dividing is equal to the thing that we ended up with, our quotient, times the thing we were dividing. Now, also, sometimes things don't evenly match up, evenly divide out, and we have a remainder. So, in that case, our f of x divided by our g of x is equal to our quotient of x, or q of x, plus our remainder of x over g of x. In other words, our f of x is equal to our quotient times our divisor plus our remainder. Alright, so the way this plays out is if we have 2x squared minus 5x minus 3 divided by x minus 3, and that is equal to 2x plus 1, that is the saying that 2x squared minus 5x minus 3 is equal to x minus 3 times 2x plus 1. Now, that is how things work without a remainder. Well, if we have x squared minus 4x minus 1 over x plus 1, and that is equal to x minus 5 plus 4 over x plus 1. So in other words, if we were to multiply our divisor times our quotient and then add to that our remainder of 4, that would give us our final answer. Alright, so when we are dividing by a monomial, 24a to the fourth b cubed plus 18a squared b squared minus 30ab cubed times 6ab to the negative first. Anytime we take something to the negative 1 power, that's the same thing as putting it under a fraction bar. So this is the same thing as 24a to the fourth b cubed plus 18a squared b squared minus 30ab cubed all over 6ab. Now, what we're going to do, again, is we're going to break apart this polynomial and put each term over 6ab. So this is the same thing as 24a to the fourth b cubed over 6ab plus 18a squared b squared over 6ab minus 30ab cubed over 6ab. And so we're going to divide each term by 6ab. So when we do that, first thing we're going to do is 24 divided by 6 is 4. And then this a is going to cancel out one of the a's on top, so there's just going to be 3 left. And then this b is going to do the same thing and leave just 2 b's left. Then we can do 18 divided by 6. 18 divided by 6 is 3. A cancels out with one of the a's on top, so we just have an a. And that b cancels out one of the b's on top, so we just have a b. And then we have negative 30 divided by 6. That's going to be negative 5. And then the a's cancel out, and then the b is going to cancel out one of the b's, so there's 2 b's left there, so b squared. So our final answer there is 4a cubed b squared plus 3ab minus 5b squared. Alright, so moving on. We're dividing this 9x to the ninth y to the fifth plus 21x to the fourth y to the fourth minus 12x cubed y squared by 3x squared y squared. So we can write that 9x to the ninth y to the fifth plus 21x to the fourth y to the fourth minus 12x cubed y squared all over 3x squared y squared. So we can break every term down. 9x to the ninth y to the fifth over 3x squared y squared plus 21x to the fourth y to the fourth over 3x squared y squared minus 12x to the third y squared over 3x squared y squared. And so we're just going to divide every term by 3, x squared y squared. So 9 divided by 3 is 3. X squared cancels out 2 of the x's on top, leaves us with 7. Y squared cancels out with 2 of the x's there, leaves us with 3. So that's x to the 7th, y to the 3rd. And then the 3 cancels out with 21 to make that 7. 2 x's cancel out 2 x's there, leaves 2. 2 y's cancel out 2 of the y's. So we have 7 x squared y squared. And then the 3 cancels out, or divides into the 12 to make that negative 4. X squared cancels out 2 of the x's. The y squared cancels out all the y's. So our final answer is 3x to the 7th y cubed plus 7x squared y squared minus 4x. Alright, so now we are ready to go into the bulk of what we're going to focus on today, which is long division. So long division, to do long division, we are going to divide x squared minus 5x minus 36 by x plus 4. So we use long division when we're dividing by a binomial. And we're going to use the same algorithm, the same tool that we learned way back in 4th grade, except this time we've got some letters involved, some variables, and that's going to be okay. Alright, so when we are dividing x plus 4, or dividing x squared minus 5x minus 36 by x plus 4, we're going to focus on this lead term, the x. And we're going to focus on the lead term inside. And we're going to think, what happens when I divide x squared by x? Well, what's left over is x. And so that goes there. And so now I'm going to multiply this x by the x plus 4. So x times x is x squared. X times 4 is 4x. And now I'm going to subtract this entire thing. So when I subtract x squared from x squared, that leaves me with 0. And when I subtract 4x from negative 5x, that gives me negative 9x. So now, just like with traditional long division, I bring down that negative 36. And I think negative 9x divided by x, what's left over? Well, negative 9. So negative 9 goes there. Negative 9 times x is negative 9x. Negative 9 times 4 is negative 36. And again, I want to subtract this whole thing. When I subtract, remember, it's like adding the additive inverse. Well, the additive inverse of negative 9x is positive 9x, and negative 9x plus positive 9x is 0, and negative 36, and the negative 36 added as inverse is positive 36, so negative 36 plus positive 36 is 0. So our remainder is 0, and our answer is x minus 9. Alright, so now we're going to try another one, and we're told that this one will have a remainder. So I'm going to set this up. Z minus 5, 3z squared minus 14z squared, or sorry, 3z cubed. Got to go back. Let's see here. 3z cubed minus 14z squared minus 7z plus 3. So the first thing we're going to do is look at the lead term, the z, and divide this lead term inside the box, 3z cubed by z, and what's left over is 3z squared. So we're going to take that 3z squared there. So 3z squared times z is 3z cubed. 3z squared times negative 5 is negative 15z squared. So then we're going to subtract that whole thing. So that becomes 0. Negative 14z squared minus negative 15z squared is positive z squared. So now I take this z squared, divide that by z, and that leaves us with a z. So that goes there. And now we forgot to bring down the negative 7z there. We multiply the z times the z, so that gives us z squared, and the z times negative 5 is negative 5z. And again, we're going to subtract this whole thing. So that leaves us with 0 there, and negative 7z minus negative 5z leaves us with negative 2z. And then we can bring down the plus 3. So now the negative 2z divided by z, that leaves us with negative 2. So negative 2 times z is negative 2z. Negative 2 times negative 5 is positive 10. So we're going to subtract that whole thing. So negative 2z minus a negative 2z is 0. 3 minus 10 is negative 7. So our final answer is 3z squared plus z minus 2, and then our remainder minus 7 over z minus 5. And that is our final answer. Alright, if you have any questions, please shoot me an email or a Canvas message and I will get back to you as quickly as I can.